Okay, so depending on which video you've watched, we may have added a multiply operator or not. So what I want to do is I'm going to go ahead and add in divide, since in my version it's missing, and then I'm going to finally fix the problem with factory. So I'm going to first demonstrate creating another thing like multiply test, except this time it's going to be divide test. Alright, so let's see. I'll add a new class. Okay, so I've got a lot of this already over here, so I'm going to copy it for now. And at some point, you're probably thinking to yourself, my gosh, he's got so much stuff he's copied up, he's going to have to fix it. And you're right, I'm going to have to fix a lot of stuff. Instead of multiply, I want this to be divide. And 2 divided by 12, sorry, I push 12, and then I push 2, so 2 is, yeah, that's right, there should be 6 is the result. And I need to make this class divide. It is a binary math operator. For now, I'll leave it as is, make sure my test fails. Alright, run the test. Expected 6, but was null. Alright, that's sort of what I expected. Failed exactly how I hoped. Let's see what happens. It's all green. Okay, so that got divide in there, but the calculator still does not have divide, and the reason I really wanted to demonstrate this was if you didn't watch both videos, you might have missed this little thing. I want to make sure that I've got all the operators registered, and if you look at the tests here, RPN calculator registered operators. Last time I made a couple changes. First of all, I added this, and I said in the last video, well, notice that since if it doesn't find an operator, it throws an exception. All I need to do is verify that it can execute an operator, and then if the operator works and it can execute an operator, then therefore it has the operator in the calculator and it's working well. So I'm going to go ahead and verify that by adding a test. Should be able to execute, I guess to divide, using the same naming convention as above. So I'm going to execute. This time it's going to be divide. This test will hopefully fail. It will fail. So now I'm going to fix this by adding in yet another block here. It's getting pretty ugly. Notice this doesn't verify that I returned the right type, just that it actually can execute something. So the test isn't perfect by any stretch of the imagination. Oh, that's interesting. I actually executed it, and this is something I did not anticipate. This throws an exception if I divide by 0, which is not something that I would have expected on a primitive. So, interestingly enough, I can't just do this. Well, fine. I guess I'll put a value on the stack and I won't divide by 0. That's an indication that I'm testing something a bit weird. And in fact, I'm going to fix that in a second. But let's go to the point where all my tests are passing, and then I'm going to do the thing I meant to do. So this will be a great segue into the next part, because I'm really testing these at the wrong level anyway. So I guess calculator dot set accumulator to, I'll just big decimal 1. Since I divide by the most recent thing I executed, this should pass, knock on wood. Sure enough, it passes, but it indicates a problem. I don't actually want to execute. I want to verify that I can find execute, or find divide, find multiply, find whatever. So the real problem here is I'm testing multiple things at once. So if I go back to this execute method, step 1, find the operator. Step 2, execute. And this operator, I really want to make this private method. I want to access it and make sure it finds it. Now, oftentimes you'll come up across this problem where you have a private method and you want to test it. And you want to test it sort of separate from other stuff. In this particular case, this method has a particular pattern. Based on some kind of identifier, return back something. And that's called an abstract factor. So in this case, it's a factory method. So I'm going to first make a new class, and I'm going to call it a math operator factory. So let's see. I'm just going to do this as a refactoring exercise. So I'll create a new class, math operator factory. Now, in fact, if I go back to that, I should be able to just copy this method verbatim. And the only difference is, what was a private method? It's now going to be a public method. That's the only change. So far, everything should pass and compile and run. It does. What I'm going to do now is, I'm going to new math operator factory dot find operator named operator name. What I'm doing right now is extracting to a class. I probably should put a return in there. Okay, so now I've got a math operator factory. Well, what has that done for me? It's removed some responsibility here, though this is a hard-coded relationship. That's a bit of a problem, and I'll fix that in a second. But now, if I wanted to, I can go back to, and I'm going to do this, I can go back to that, the registration test to verify that it's just looking it up. So these tests should not be going against the calculator, they should be going against the factory. So if the factory has an operator, I'll be able to look it up, and if the operator works, then the calculator should work. All right. So let's go ahead and let's do this. These tests are really about the factory. So RBN calculator registered operators test. Well, no longer are operators registered with that. They're going to be registered with the factory. So I'm going to go ahead and I'm going to rename this. All right. So how's about that? Okay, cool. Now what I'm going to do is math operator factory. Okay. So now what I'll do is instead of should be able to execute add, I'm going to leave the name the same, but factory dot find operator named. That should work. It does. Get rid of this one and should be able to find add. Okay, great. Now I'm going to do that with the rest of these. Should be able to find, subtract, I'll run that. Good. Should be able to find factorial. Run this. Excellent. And should throw exception for unknown operator. Great. Name is fine. Alright, now just to verify that this is in fact doing something rather than just getting a test that was passing to still pass, that should fail. There we go. Expected exception, but it didn't happen, so let's go back to what it was. Alright, and finally, should be able to find multiply. Okay. Everything's passing, and then finally I should be able to get rid of that. Now notice it's failing right now because I was doing both execution and lookup, but now excellent. That's better. And I got rid of that little hack in the test. But that little hack in the test should set your spider senses tingling. Hey, you know what? I'm testing maybe at the wrong place or something. Alright, organize my imports and save it. I've still got a warning. Let's go ahead and fix that warning. Ah, yes, I no longer need that. So better. Now I'm going to go and fix the factor up just a touch. I don't like all these instantiations, so I'm going to go ahead and I'm just going to change the implementation here. So let's see, a map of string to math operator. Let's see, concurrent hash map. I'll use concurrent hash map because the concurrent hash map, while it takes up a touch more memory, is faster than your other maps. It actually breaks up the table into multiple sections and it uses multiple locks. So even in a single-threaded environment, it's not going to make any difference. It's going to use a little more memory. In a multi-threaded environment, it's going to be faster. So it's always faster than your typical maps. So I'm going to use it instead. Now I'm going to just register operators. Create that method. Great. So I guess operators by name dot put into plus new add. Okay, I got minus, divide, multiply, factorial. Now that I've done that, make sure everything still runs as expected. Everything's running. So now I believe I should be able to do this. Alright, slight improvement. Now it's going to be a little bit easier to register stuff. This still isn't quite safe because, for example, what happens if someone does the following? Later on, someone, say, creates a new operator. They inadvertently put in the wrong operator, and I put in something, well, let's say I wrote that right there. I've just overridden plus. In fact, right now, if I do this, it'll cause some tests to fail, I believe. Yeah, because plus, add two numbers correctly, expected 7 but was 24. Alright, well, that's a problem, and for right now I'll leave that as an exercise for you to fix. But it's not that hard to fix. There are a couple things I would do. First off, instead of just directly modifying this, I would maybe write a method. For example, register new operator, passing in a string and a value, and if the string is already used, I throw an exception. Other thing I would do is I would change my tests so that it verifies that when I look for plus, I actually both get back something and that something I get back is actually a plus. But in any case, I've now got this as a separate factory. I want to go back though for a second and go to the calculator itself. This is a hard-coded math operator factory. Right now there's no support for dependency injection, which means that factory is always a factory that's going to be used. All right, I don't want to do that. I want to actually I want to go ahead and allow for variance in my factories for any number of reasons. So what I'm going to do is I'm going to continue doing a little more refactoring. First of all, I'm going to take this math operator factory and I'm going to extract an interface. So let's see, refactor and extract an interface. Now, math operator factory, I'm going to take a step back. That's a good name, and I want that to be the name of my interface. So since I want that to be the name of my interface, I've just created this. It's safe for me to rename this class. I'm going to call this, how's about short named operators math operator factory. It's a bit long, but I think I'll get the point across. Now that that's out of the way, that good name's out of the way, I'm going to refactor that, and I'm going to extract an interface, and this time I'm going to call it math operator factory. Great. And let's go ahead and create this interface. Great. Now that didn't really do much. If I just run my test, everything should be working. Great. If I go back here, notice it's got a direct relationship to this. I want to fix this. I want to change this. First of all, I'm going to do a couple steps. I'm going to take this and I'm going to turn it into a local variable. Alright. Now I'm going to take this local variable and I'm going to rename it. Let's see. Let's rename it to just factory. Okay. Now I'm going to take this factory and I'm going to turn it into a field. Oops, I went a little too far there. Now I'm going to take the initialization and I'm going to move it into a constructor. So I'm going to copy this up here. Public RPN calculator. And I'm going to take this down here and move it up here. That shouldn't really change anything. That should change anything. It should change things because I copied the wrong line. Let's see, am I still running? Okay, great, I'm still running. Now, it's a little bit cleaner. What I want to do is I want to support providing a factory as opposed to always having a factory. One thing though, I want this to be math operator factory. I want to work with the interface. Okay, so now public RPN calculator and math operator factory. Great. Shouldn't break anything, just added a constructor. Okay, should work fine. Everything works fine. Now I can provide my own factory. Now, why the heck would I do that? I wanna show something here. I'm going to rewrite a test in place, and the reason I'm going to write it in place, I really don't want to make a whole other class for this, but you're going to see we have this thing that verifies that certain operators are registered. All right. Right here, I have to provide a bogus value, bogus blah 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 operator. Okay, well that's fine. But what I really want to do is I want to verify that given a factory, if the calculator attempts to use an operator that is not known, then it will not swallow the no such operator exception. All right, so I guess I am going to create a new test for this. So let's create a new test class, a new class, and I'm going to call this RPN should not handle unoperators. It's a long name, but let's see if I can write a test. Okay, so foo. I think the name of the class is the name of the test, but let's go ahead and call it foo until I figure out what I'm going to actually do here. So I'm going to create a RPN. let's see. I'm going to create a thing called a saboteur. A saboteur is a class, a test double that always fails in some manner. And rather than using Mockito, I'm going to hand roll it, and then maybe I'll convert to Mockito if I'm feeling like it at the end of the video. So I'm going to create a math operator factor. So private static class that's not what I wanted. Oh, right, I have an interface. This is perfect. Alright, now I need to add the method. And what I said was I want to always fail. No such operator. Alright, so now what I'll do is I'm going to create a calculator. Math always failing factory. So now when I say calculator.execute, now watch this, this is the key here. Execute plus, I want to verify that it throws the exception. All right. I'm going to run this test, and it passes. Now, you think, well, that's not a big deal. I'm going to remove the factory. I'm going to just not use that factory. If I run this test fails because it didn't throw the exception. But if I put back in the saboteur, and I execute, first of all, I have verified that when I don't find a particular operator in the factory, the RPN calculator class allows that exception to bubble up on through. That's what this test does. Second, I've taken complete control of this test. So I'm testing that the calculator does, or in this case doesn't do something, and I did that by controlling the one variable that is important, that is the factory. I've created a test double here. I hand rolled a test double, but I could have used Mockito for this, but I decided to just hand roll it. And now I've got an abstract factory. That's math operator factory. I've got one concrete implementation that uses a hash map, and then it maps a string plus divide, subtract, multiply into a single instance. And then I've got the other one that is just for test purposes that always fails, also known as a saboteur. So I've introduced the abstract factory pattern into my calculator, and if I go back to the calculator, and let's look at this calculator, it's getting smaller. There it is. It's got a stack, it's got a factory, it's got this old sort of backwards compatible constructor, this new one that I just used for the new test. This allows for dependency injection. I inject my own test double that allows that one test to pass, and then I've got peek, replace top, blah blah blah, execute, and find operator. This thing is pretty closed right now. I don't think I'll need to make any more changes to the calculator. I might, but it'll be pretty minor. At this point, I think this is a good stopping place. What we're going to do next is we're going to allow for composite operators. I guess before we do that, we're going to add a few more operators in. Hope you enjoyed this video, and hope to see you at the next video. Good night.